Sure.
Okay.
Yes.
Yes. Chapter 9.1.
Mm.
The exam is 9.1 to 9.4 and 10.1 to 10.3. Yeah. Which one? Okay. So this question, we have two groups. So the main group, this is the sample size, 1,427, and this is the successes, okay, 411. And here we have the women, 752, successes, 230.
Okay.
So the claim is that men and women have equal success.
Not equal to.
Yes. So H0 is equal and H1 is not equal. So now we have to find the stat. Open stat crunch. Down.
Consider for example,
We go to stats proportional.
Yeah, stats, proportion stats, to sample, summary. So when you have P in the hypothesis, that means it's proportional. P1, P2, that means two samples. So we'll put,
P1 is males.
yeah, no, here it says first sample, males. So
Okay.
sample one, yes. So we'll put 4, 1, 1, successes, this one here, and this one, success. A stat crunch, two proportions, proportion stats, then two samples. And then we put observation, 1427, and then for the females, we put 230 successes and 752 for observations. And now we'll have to check, okay, same signs, everything is good. We'll compute. And we have our Z stat, we'll copy paste, and we have to round up 2 decimals. So it becomes 7.
two samples with summary, right?
Yeah, 2 samples with summary because they didn't give us a table with that answer. Okay. So we copy p-value as well. 3 decimals, so we'll remove 1. Okay, next. So p-value is more than 0.05. So because it's more than, we're gonna fail to reject, and when we fail to reject, there is no sufficient evidence to originate claim. Okay. Okay, good. Now we have to find the confidence interval. So we go back to StatCrunch, edit, and then here, confidence interval. You know, same number, 95%. It's here. Compute. Copy the upper limit, and we have to do 3 decimals, so it will become 3. Lower limit. Okay, move 2 because 3 decimals. So negative to positive, that means 0 is in between. So it includes 0. And when there's 0, that means there is no difference. So there does not appear to be a significant difference between the two proportions. So there is not sufficient evidence to reject that they are equal because 0 is there. Okay, check. So based on the results, do women and men have equal chances? So yes, there is no difference between them. Okay. Question 1 finished. Next. Okay, here we have two groups. The first group are people over the age of 55. The second group is people under the age of 25. So 285 people over the age of 55, 76 of them dream in black and white. And here we have 312 people under the age of 25, 18 of them dream in black and white.
People over age 55, it's greater, right?
Now here we need to check the claim. Yes. Yeah, the claim says that the proportion of people over 55 dream in black and white more than or greater than the proportion for those under 25. Okay?
Absolute hypothesis
Yeah.
is correct.
Yeah, and the first sample is people over 55. So P1 is going to be more than P2. Answer is that. So next, we'll go to StatCrunch. We have P in the test, so we'll do
P1
proportion
is what?
Good sample.
summary. So we'll put the successes 76 and 285. Don't put 55 because that's the age of the group.
2
Yeah, 55 is the age of the group. Don't put it. You don't use it to the calculation. Okay, so here, 25, we don't use it. It's the age of the group.
Why did it give you a mistake?
18.
Hmm?
Why did it give you a mistake?
No, there's no mistake.
Oh, I saw a lot of
P1 is the age 55, yes?
55.
Oh.
So
55, right?
312.
Oh, okay. Yeah, that's it.
No, 55 is the age of the group.
Oh, okay.
Okay, we don't use it for the calculation. It's only to distinguish between the two groups. People, group 1 or sample 1 are people over the age of 55. Sample 2, people under the age of 25. But it's not used in the calculation. It's like having males and females, you don't use it in the calculation.
And then we put less than?
Okay, and then we put more than.
More than.
Yeah.
Okay.
Because P1 is people over 55, and people over 55 are greater than those under 25. So we compute. We have Z stat here, and we round it up to 2 decimals. So we just put in p-value. It's really small, less than 0.0001.
We put 0.
That means it's 0. And then we have the p-value. Okay, it's 0. Compare it to alpha, 0.05.
It's less than.
So it's less than. Less than means reject. Reject means sufficient. Okay. Now confidence interval. Go back to
I don't
StatCrunch.
if the p-value is greater than, it's automatically fail to reject, right?
Yeah, fail to reject. If p-value is less than or equal to alpha, we reject. If p-value is more than alpha, we fail to reject. So we go back to StatCrunch. We edit. Scroll down. Confidence interval. And here we have the percentage 90, and we'll compute. Copy paste. And they want 3 decimals. So here's 4 and 2 round down. And lower limit. Now here 4 decimal, we round to 3, we'll get 1. Good. So we only have positive numbers.
Only
Okay?
positive.
So we only have positive numbers. That means they dream more in black and
Greater
white.
than.
So greater than. So here is the result that we got here. Does it explain why people dream in black and white? So no, because the statistic doesn't really explain why people dream in black and white. It only explains the proportion. Okay, so anyone could dream of black and white because they maybe got sick, maybe they're colorblind. So watching TV isn't really the main reason that makes them dream in black and white. So no.
No, but what's the reason?
So we have 2 no's. The first one says the results are not statistically significant enough. We said that logically it doesn't make sense that people dream in black and white because of TV. So here, look, the results cannot be used to verify the cause.
The first one
Yeah.
was statistically, but statistics say it's greater than, yes? So it's
Yeah.
not accurate.
Now it says greater than,
Yeah.
but you can't verify it statistically.
So D.
Yeah, it's D. You can't explain statistically why people dream in black and white. You can only find the proportion. Okay, so next we have to, let's see here, we have 2,978 occupants not wearing seatbelts. 31 were killed. And then second sample, we have 7,664. And 15 of them were killed. So we have 2 samples, okay? Sample 1, sample 2. So
one sample just mentioned seatbelt.
Yeah, the first one, no seat belts. The second one, they are wearing seat belts. Okay, so here we have the claim that seat belts are effective in reducing fatalities. So people won't die from wearing a seat belt. Okay, so first sample is not wearing seat belts. And second sample is people wearing seat belts.
Not equal.
So,
Not equal,
no, no,
because
no. That's
it
the claim
says-
that,
It says none here.
okay, look here.
Okay.
Test the claim that seat belts are effective in reducing fatalities. Okay.
So,
Reducing it mean less than?
Yes,
reducing, so it's less
reducing.
than.
So that means P1, people not wearing seatbelts. P2 is people wearing seatbelts. And so they reduce fatalities. That means people die more in not wearing seatbelts. Did you get it?
P1 is people not wearing seatbelts?
Yeah, P1, right here it says sample 1, people not wearing seatbelts.
Yes.
P2 is people wearing seatbelts. Right here it says, second
So,
sample. Yeah,
why do you say it's more than like
more than, because look, look at the proportion. Right here it says people who were killed.
31?
Yeah,
Okay.
so we're getting the proportion of people who died,
Oh,
right? So, and we said here that P2 reduces the amount of death. That means also that P1 is more than P2.
they searched them, yes? Or no?
Now here, look. Test the claim that seat belts, so P2, is
Yeah.
effective in reducing fatalities.
Yes.
So that means P2 is less than P1.
So 31
Yeah.
plus
okay.
15.
No, the numbers don't matter. No, the number you just have to look at the claim. Okay, the words matter. The numbers don't. The numbers you're just gonna write it in StatCrunch. Okay, that's it. You don't conclude your hypothesis test on the numbers. This is your claim. So stat, proportion, to sample, summary.
P1, people not wearing seatbelts, yes?
Yeah. So successes, we'll put sample 1, people not wearing seatbelts, 31. Then 2, 7. Okay, 2, 9, 7, 8. Then successes of the second one, 15. Observation, 7, 6, 6, 4. Okay, next. We'll change the symbol to more than. And then we'll compute. We have this stat.
Wait, for example, it's not wearing seatbelts, yes?
Yeah, not wearing seatbelts here. It
So it's
says
P1,
P1, yes.
the people not wearing seatbelts.
Yeah, because it says here, look. First sample to be the sample of occupants not wearing seatbelts. So P1. Okay, so here we need 2 decimals. Now we have 3. We'll round 6 to 7. Check. Good. And here we have less than 0.0001. That means 0. And then 0 is less than 0.01.
So less than.
So we reject. And when we reject, there is sufficient evidence. So now we'll edit. So they didn't give us the confidence level. So we're going to calculate it. So we look at H1. If it's equal, if it's not equal, that means it's two-tailed.
Okay.
If it's greater than, that means it's a right tail test, one tail. And if it's less than, that means it's a left tail test, also one tail. So if it's more than or less than, it's one tail.
One tail.
And how do we calculate the level for one tail? We do 1 minus 2 alpha. So 1 minus 2 times 0.01.
So 98.
Yeah, 98. And then we'll copy paste.
1 times 2 minus alpha, right?
Yeah, if it's one tailed, 1 minus 2 alpha. If it's two tailed, it's 1 minus alpha. Okay, so here we have 4 decimals. We need to do 3, so we'll round 2 to 3. And now we'll copy this one, we'll paste. Here we have 4 decimals. We're going to round it up to 4. Yes, excellent. So now, positive to positive. That means does not include 0. So that means they are not equal because there is no 0. Because the confidence interval only includes positive values. That means the fatality rate, that means people who die, is higher for not wearing seatbelts.
If it's equal, it's mean 2 tail or 1 tail?
Where? Here. You look at H1. If it's not equal, it's two-tailed.
Okay.
If it's more than, it's one-tailed. If it's less than, it's one-tailed.
One third is the one where we do.
Yeah, we do
alpha.
1 minus 2 alpha.
Okay.
And for two-tailed, it's 1 minus alpha. Okay, so what does the result suggest about the effectiveness? So the results suggest that the use of seatbelts is associated with lower fatality because we just proved that people die using not using seatbelts is higher than people who use seatbelts. So A. Good. I'm gonna check the tier tutors if anyone's coming.
What did you offer for the multiple choice? That's
So
this one would be
which one?
the multiple choice results.
Yeah, we proved that people who don't wear seatbelts have a higher fatality rate. That means so people who
fatalities. Okay.
so people who wear seatbelts have less fatality rates than people who don't wear seatbelts.
Okay.
Okay. Next, I have to check if any students are going to join us online on Teams. So okay, let's continue. So here we have rhinoviruses. So rhinoviruses typically cause common colds. And then we tested effectiveness. It's in Nika. Okay, so this is the first virus, I think.
Okay.
Okay, or the treatment maybe. Yeah, this is the treatment. So 35 of 42 treated with this developed rhinovirus infection. And then in a placebo, 95 of 108 developed the virus. So this is sample 1, sample 2 depends.
Okay.
So those who were treated, these are those who were treated are sample 1. And the second sample are those who were treated with a placebo.
Yes.
So this one, sample 2.
Sample 2.
So this is P1 and P2.
Sample 2 is it greater than?
So we have to test the claim that
Has an effect.
that the treatment has an effect on the virus. So that means it's more than.
More than.
Yeah.
Wait, why is this more than?
Because we need to check the treatment. Okay,
Oh,
test
so
the claim that they have more of an effect that.
It came from your own. Greater than. What is
What is
that? It's almost the same one. Effect.
Okay, wait. Let's look at the X. Okay,
This one a little bit.
we'll test the effectiveness of the. Okay. Okay, so let's look here. So 35 out of 42. So we need to check what is the X, the successes. If they say that the people were treated who were cured, that means P1 is more than P2. But here it says people developed the infection. So people got sick.
Yes.
Got sick. So that means sample 2 with the placebo should be more sick than sample 1.
Because the more
Yeah.
of them got sick than the.
Yeah, because this one says it has an effect on rhinovirus infection. That means it treats it. But that also means that placebo group
It's also
got more sick. What?
بعطل.
It's wrong.
Not
it's
equal
not
to.
equal. Maybe that it's not equal. Okay, for some reason that's the answer.
Maybe because it says what are the null alternative hypothesis. Maybe.
No, it's not that.
It's 0.
Test the claim that Chinaika has an effect on rhinoviruses.
This one's confusing.
Okay, so it says it has an effect on rhinoviruses.
Yes.
So that means the opposite, that it doesn't have an effect.
So how did you know that it's not equal?
Look, the test says, test the claim that Echinaika has an effect, okay? So what is the opposite of having an effect? Doesn't have an effect, yeah.
Nothing.
So if it does have an effect, that means it does equal, then the opposite, H1,
Not effect.
is not equal, does not affect. We'll close this one. Go to stats, and then proportion to sample, summary. So sample 1 is those who were treated, 35, 42. 95, 108. So we compute, we'll put the stat, 2 decimals, p-value, copy p-value, here, round up. P-value is more than, so we fail to reject, so there is no sufficient evidence. So the interval we'll have to edit. Confidence interval, they give us 95%, we'll use it. Copy paste this one. Copy this one. Here, so here we have 4 decimals, round up to 3. So it includes 0. That means there is no difference between them. That means there is no evidence to conclude that it has an effect.
Once there is an include 0, it automatically does not appear. Right?
It depends on what they say. It depends on what is said here. So here it's so we have 0. That means there is no difference between them.
And there is insufficient level.
Yeah, there's no significant difference between the two. There's no significant difference between the two. That means there is no evidence to support the claim. Okay. So here, what did we find? So the first one says it does have an effect. Wrong. Does have an effect. Wrong. Does not have an effect. Okay, next. So we have here. So among 323 infants using bed nets, 12 developed malaria, and among 276 infants not using bed nets, 29 developed malaria.
So this round, this round.
So we have to test the claim that the bed net is lower for those who claim that malaria is less for those who use bed nets.
Bed nets is lower.
Yeah,
it's
so
going to be-
sample 1 is bed nets,
So it's less than.
sample 2
And that's
not used.
P1 and the malaria is P2, right?
It will be less than.
So
will be less than.
P1 greater than P2.
No.
Here is P1
P2?
less than P2. Okay, so we have to go to
P1 is
stat.
malaria?
P1 bed net ولا أقل.
So we'll go with proportion stats to sample summary. So sample 1 bed nets, so we'll put 12, 3 to 3, 29, and 276. And we'll put less than, compute. Have the statistic, put it, 2 decimals, p-value, round it up 3 decimals, 1. So p-value, where is alpha is here, 0.05. Less than, so we reject. So we need to use the interval. So they didn't give us the level, so we have to calculate. So here we have less than, that means it's one tail. So 1 minus 2 alpha. So 1 minus 2 times 0.05. This will be 9. We'll copy, paste, 4 decimals, round up to 3.
negative positive.
And here we'll do it. 4 decimals.
If it's
Wait, okay.
negative positive, it doesn't include zero, right?
Include zero.
Yeah, negative to positive, that means there is 0.
Okay, wait.
There is zero.
For me, I put the bit in sample 1, yes?
Bednet sample 1. No, you not bednet, so sample
Oh,
2.
wait. No, I put them in the wrong way.
So does not contain 0. Right here, look. From negative to negative does not include 0.
Okay.
If it was negative to positive, it does include 0. That means there is a 0 between them.
So now, is it right?
It does include 0. So there is no difference between them.
It's not.
There's not. Yes. No, it's here.
It's not.
There is
It's not.
It's not.
Okay. Let's back to this question. Okay. So it does not include 0. That means there is a difference between them. Okay, here we have to test the support the claim that it lowers. So there is sufficient evidence. There is sufficient evidence because we rejected the null hypothesis. The null hypothesis says they're equal. If we reject it, that means we say no, we don't want this. Yeah, that means they're not equal. Okay, so evidence supports the claim that it's lower. So bednets appear to be effective. So there is sufficient evidence. So bednets are also effective. Good. Next. So here in this question we have 2 samples. The first sample is passenger cars, K2187, and 244 had only rear license plates. And then we have second sample, trucks, 342, only 50 had rear trucks. And the claim is that commercial trucks violate more laws than passenger cars. So remember, trucks more than cars.
So greater,
Yeah.
greater than.
Yeah, and then
She,
look, P population 1 is cars, P2 is commercial trucks. Okay, so P1 cars, P2 trucks, and we said trucks is more than cars. So P2 more than P1. So we have to use this now, stat crunch, stat proportion to sample summary. We put the successes. Sample 1 is passenger cars, 244, and then 2187. Then we put 50, and then 342. Then we put less than, and then we put compute, and we'll get the z stat. Put z stat. So round to 3 decimals.
What is
Comes
the
6.
claim here?
The claim is that trucks violate more laws than passenger cars.
Okay.
Okay, now we need to get p value.
P2, yes?
Mm.
Okay.
So compare p value with alpha. Alpha 0.1. So p value is less than. If it's less than, we reject. There is sufficient evidence. Now we need to find the interval. So they didn't give us the confidence level, so we have to calculate it. It's one-tailed, 1 minus 2 alpha. So 1 minus 2 times 0.1. So it will be 8. Compute. For this one, 4 decimals. So here we have 5 decimals. Round up. Here, let's go. 5 decimals. Round up because it's 8 before 5. Good job. Okay. So negative to negative, there is no 0. If there is no 0, that means there is a difference between them. And so there is sufficient evidence that commercial trucks violate more laws than the passenger cars.
Okay, so when we round to this one 5.
Yeah, becomes 9-0, becomes 2. Becomes 2. Becomes 200.
This one round to 2 decimal.
Mm.
So what does it become? This one is 5.
Yeah, becomes 2. Yeah, adds 1. This one becomes 0. It adds 1 to 9. Becomes 0 and then adds 1.
Like this?
No, that is yep. Becomes minus
1.
2.
Ah, 2.
Yeah.
Okay.
Yeah, it adds 1 to 9, and 9 adds 1 to the other 9, and 9 then becomes 10, adds 1 to 1.
Okay, I get.
Okay. So professors collected data consisting of eye color and gender of statistic students. So here we have sample 1 male students, sample 2 female students, and we need to test the claim that blue eyes are the same for males as females. So easy. This one. H0 equal, H1 not equal. Okay, now,
We don't put for that one.
which one? This one? No, H0 always equal.
Greater than is
Yeah.
reject.
Yeah, so this is wrong, this is wrong, and this is wrong. H0 null is always equal. So two sample summary. So sample 1 is males, so we put males, 333, 882. Second sample is females, 9393, then 1147. Okay, this is the same. Then we compute, copy Z stat, round up, 3. P value, copy, paste, round up, 4. P value is greater than 0.05. That means we fail to reject. That means there is not sufficient evidence. Okay, now they gave us the level, so go here, 95%, same. Copy this one.
1 minus alpha.
Okay, let's click on this. No, we don't have to calculate it. They gave us.
Oh,
Okay. So now 3 decimals. This is correct. So it includes 0. That means they are equal. So there is no look. You have to read. Okay. There is no sufficient evidence to support the claim that the proportions are different because they are equal. They're not different.
If it said it was the same, I'd have to put sufficient evidence.
Yeah,
Yes?
yeah. If they said the same, then we have sufficient evidence to support it.
Okay.
So this professor, he asked his student,
Convenience.
so it's a convenient sample because it's easy to get for the professor. So now we have to think about how they use the sample. So is it biased? No, it's not biased because they didn't compare it with the population. He only got the proportion and that's it. He didn't compare it to the general population. Okay, next. Sample 1, people write with their left hand, and 212 do not. Sample 2 is that we have females, 69 write with their left hand, and 455 do not. So the claim is that males less than females, and sample 1 is male, sample 2 is female. So P1 is males.
This is the one
And
where
P1
we,
is less than.
this is the one where we add both of them.
Yeah, you add them because they have separated the.
Yes.
Yeah, they separated.
We add both of
So
them.
we go to sample summary. So
What
here,
was the claim?
17.
Left-handed and movement is yes.
Then you can do this one right here, add. And then we have here 69. 69
It would be
plus
less than, yes?
4, 5. Less than, yes, less than. But then we compute. We got restart. Because here it says 17 write with their left hand and 212 do not. That means they write with their right hand. Okay? So you have to add them to get the total.
وما اعطاك التوتال قسمهم اثنين على طرف.
يعني سكسس هذه
يقول لك
عقب الثاني
يقول لك 470 ومنهم 23 يعني هذا توتال مالهم بس اذا يقول لك 23 جديد والباقي 260 تجمعهم.
P value. So P value is less than. That means we reject. That means there is sufficient evidence. Good. Now, they gave us the level, so we'll go edit. And we'll put 90. New per limit. So they want 3. Okay, now we have 4. So round 9 becomes 10, and then you add 1 to the one after. So this one becomes 2. Now we'll copy the lower limit. So here we have 4 decimals, round up, becomes 5. So only negative values. So there is no 0, that means there is a difference. So we have evidence to support the claim that males less than females. So it is reasonable because we proved that males are less than females. So there is sufficient evidence to prove it. Okay? It is reasonable to conclude that the rate of left-handedness among males is less than the females. So we finished this one. So next,
Greater than is better. Yes.
discussion of the sample size. What is this? I don't know. I don't think this is coming in the exam.
والله.
We're not gonna get this one in the exam.
This one.
So we have first sample, second sample. The hypothesis test says P1 equal P2.
So not equal.
So not equal. First, this B. So test statistic, go here, close this. T proportion to sample, summary. Sample 1, 19, then 40. Second sample 1, 5, 2, 6, and 2. Good. Copy these start. Put it to round up. Critical values. Just do edit. Show critical value. And we'll put the alpha. Then we have critical Z. So it's two-tailed, so we'll do 2 critical values because it's two-tailed. Wait, it's 3 decimals. What was it? Yeah.
Question 14 now.
So we'll do this.
Wait, how do we identify the critical value?
We'll go here, edit, click on show critical value, put alpha, yes.
And then to choose that one.
Yeah, choose. So here, test statistic. So this one is more than the negative, so it's in. If it's in, we reject. That means there is sufficient evidence. Okay, now we do confidence level,
This one, the first sample is P1, yes?
P1.
First sample.
Copy this one, paste, we need 3 decimals. Because the test statistic is greater than the negative one, so it's in the region.
Isn't it the opposite?
Bigger number. If the number here is bigger than this one, it means it's in the critical region. You don't have to look at the sign. Okay, so ignore the sign, look at the number. If it's bigger, yeah. So if this was positive, it's still bigger than 1.96. So it's in. And then with the negative, the number is still bigger, so it's in the.
How did you identify the critical values?
So the critical values, go edit,
Yes.
and then show critical value, and then you'll get the positive one. And because it's two-tailed, you'll put the negative one as well. When it's two-tailed, you have 2 critical values.
Okay. It will give me 2 if I.
Yeah, if it's two-tailed, we have 2 critical
You
values.
put the significance level 2?
Yeah, it's 0. How much?
0.04.
0.5. You put a significance level. So the results. So here we rejected null hypothesis.
For me, I put it
Here
minus.
we rejected null hypothesis. You round it up here. Okay, so here, because we reject here and reject here, so there's same. That means hypothesis test says P1 not equal P2. And this one, because it's the same, it's also not equal. We finished. So next. I don't think it
I
will come.
still don't understand the critical value.
Okay, we finished 9.1.
Critical value, this one, 1.95.
Yeah, rounded up 3 decimals.
So it's 960 to the come?
Yeah, 1.960.
0. Okay, fine. There are a second value need to put.
9.1, 9.2, 9.3, 9.4.
What's the second value that I need to put?
The negative. The same number, but,
I
but
do
negative.
that
Yeah.
comma like this right away?
Yeah,
or
comma and then put negative.
Negative 1.9.
So here we have to test the claims. Okay.
Okay.
Let's go here. So this,
What happens when for this one? The test statistic?
yeah, the number is bigger, so it's in.
Which one?
This one, it's bigger than this one, the negative one.
Okay.
So it's in.
That's
It's in.
Okay, so
So we reject. So there is sufficient. Okay, here 9.2. We have the claim here. It says giving candy does result in greater tips, and giving candy is mu2. So mu2 is more than mu1. This one. Okay, next we have test statistic. So we have mu1, mu2, and we don't have the population standard deviation. So what we'll do is t-stats to sample summary. So we'll put sample 1, mu1. The mean is 18.01. Standard deviation is 1.33. Sample size 40. And then mu2 is sample 2. We put 20.49 and then 2.514 standard deviation and then 40. And we'll copy this right here. It's less than, put less than, compute. Then copy t-stat, paste. There we go. P-value, it's 0. So 0 less than alpha 0.01. So we reject and this is sufficient. Now we have to do the interval, edit, go to confidence interval, and it's one-tailed because left. So 1 minus 2 alpha will get 9/8. So we copy this one, and then round up to 2 decimals. Here, same thing. Here round to this. So the confidence interval has the same result. Okay? Because it only has negative values. Because it only has negative values. Okay? So here we said reject the null hypothesis. That means they're not equal. So we have sufficient evidence to support a claim that giving candy does result in greater tips. And look here, mu1 is no candy, mu2 is giving candy, and mu2 is bigger. So when you do subtraction, you'll always get a negative number.
Wait, I want to ask, how did you identify the new one and new two?
Here, in the table.
It's given?
Yeah, it's given.
But sometimes when it's not given, how do I identify it?
We'll do more questions. If we have one like that, we'll
Sample one, which one is be the one with the higher number or
sample 1 is mu1.
U1?
Yeah, and sample 2 is mu2.
Oh, okay, it's already there.
So here we have another one. So we need to test the claim that 2 samples are with the same mean. So H1 is that they're not equal. They're not from the same mean. So test statistic, we go to edit. No, it actually close. We'll open a new one. T-stat, 2 samples, summary.
Yes.
And here, U1 is,
32.
no, mean is 2.39.
Okay.
Standard deviation 0.52. And 32 for sample size.
268,
And then 268, yes.
0.85.
4, then 85, 40.
40, 30.
And then we have the same compute. Copy t-stat, paste, 2 decimals, with p-value, copy paste. So we'll have to round up. So this will become 10, so this will become 8. You can put 0. So because compare p value with 0.1, it's less than, we reject.
No,
So we
it's
have
sufficient.
sufficient evidence.
If it's greater than, fail to reject.
Fail to reject, yes. So edit. So it's two-tailed. So 1 minus alpha. So 1 minus 0.1.
1 minus 0.10.
So it's 90. Copy this one, paste. Round 3 decimals.
If
Here.
it's 1, if it's 0.99, we put this.
No, it's 0.1, not 0.01.
Oh, 0.1, okay.
So 3 decimals. This one becomes 2. And so we finish this.
إذا ما أعطاك confidence خلاص أنت تسوي على طول من الآن.
So here we have summary stats. Let's look.
Now it's
So,
okay.
so we need to test the claim that blue enhances performance on creative task.
Okay.
So blue is more than red. Blue is U1, so U1 is more than U2.
What gave you this idea?
Come on.
Here, look. U1 is blue, U2 is red. And blue is more than red. You know, it says here, enhances performance.
Oh, nice performance.
Yeah. So it's better. Enhances because it means greater than. So we'll close the old one, stats, T stats, to sample, and summary.
Summary, yes.
So we'll put U1, blue, 3.88, standard deviation 0.55, 32, 3.17, 0.84, 50. And then here we need to put greater than, compute. So we will copy T stat, and then
Okay, okay, 2.
we check teams. Okay, done. Wait, what happens? Why is there another sound?
Maybe in your phone?
Oh, someone called me.
Is it to the record?
No, there's another student who's
Trying to enter. So, save
wait,
it.
I'm gonna maybe no, I can maybe
Stop.
give him a link. How do I link?
Okay, you can stop, then you can give him the link.
keep the record.
No, I can maybe give him the link so he can join, but where? Where can I get it?
Open the chat
There.
Chat.
and
There should be another link, like invite, so he can only join the meeting, not the whole group.
Okay.
Wait, this one? No, there's no.
No,
Okay,
yes,
share invite.
Share invite, yeah.
Okay, copy
yeah.
here. So we move this one. Right. Okay. Okay.
IT.
So we go back here. So let me check.
شباب المستقبل صادين
Yes. So let's continue. Copy. Wait, let me go back here. P0.
Why it's 0? What is the p value?
Cause less than 0.0001.
You told me.
So 0 less
Reject.
than alpha. Where's alpha here? So no, reject. P value less than alpha.
Less than.
What the p value is less than alpha?
Yeah, p value less than or equal alpha, we reject. If we reject, there is sufficient evidence. Okay, so next.
That isn't gonna.
So we go here, we'll edit,
1 minus.
confidence interval. So it's one tailed, 1 minus 2 alpha. So 1 minus 2 times 0.05.
0.95. 95?
ما زيرو
No, it's one tailed. 1 minus 2 alpha.
2.
Yeah.
هني
2.
So 2 decimals, round up.
If it's 1/3, it's
So here we'll do
يكون 95 طلع
So we're doing here
minus 2 times 0.
only positive. So there is sufficient evidence to support the
صراحة.
هذا التيمز ولا
صباح الخير.
yeah teams of
ها؟ هذا مسير لا؟
الحين
Yeah.
يسجل.
okay. So here we have two groups.
اوكي
Reduction level. So we have magnet treatment and sham treatment. So mu1 is magnet, mu2 is sham, and magnets are greater than sham. So mu1 is greater than mu2. So we go here, close, stat. Because it's mu, we'll do T stat. To sample, because we have mu1, mu2. Summary. Wait, oh, mistake, wait. T stat, to sample, summary. So we put mu1, mean 0.48, standard deviation 0.91, and 29. Mean 0.0.13, then 1.21, 29. And then we have to put the same symbol, more than, greater than,
Yes, greater
greater than, compute.
compute you get
T stat, copy, T stat, paste. Right. P value, copy, paste. So it becomes 3. You don't have to write the 0 if it's at the end. So P value, it's 0.43, greater than 0.01. Failed to reject. So there is none. So we'll do
the competency table.
Edit.
It's one table now.
it's 1 tail, so 1 minus 2 alpha. So 1 minus 2 times 0.01, 98.
ضرب كم؟
0.01.
What is it? 0.01.
Yes.
0.98
Yeah, 98. Then we did it, put the values.
If it's two tails, just one minus
Alpha, yes.
Yes.
You know it's one tail when there's no confidence interval, right?
أنا بسوي براكتس يعني.
So,
أعطيكم shortcut.
so magnets are effective in so does it appear that magnets are effective in treating back pain? Because we have 0, that means no. So it appears, yeah, so no, it's not effective. So it appears that magnets are not effective because 0 is in the interval.
الانترفال 0 لأنه ماينس و
Yeah, if there is 0, that means they're equal.
يعني ماشي فرق.
if it's minus, if it's positive, what will it be?
يعني
Okay, so here,
minus less
That's
than.
not.
إذا minus
okay, so here,
ماشي فرق. فاهم؟
okay, look. So here, is it valid to argue that magnets might appear to be effective if sample sizes are greater? No, I don't think. Is it open? No.
بطل paint.
Paint? Yeah, I guess we have to use paint.
The classic خلاص ما.
You have to go old school. Is there paint in this computer?
No.
Nice, we have paint. Okay.
ترجع الأسئلة.
Okay. So here it says, is it valid to argue that magnets might appear to be effective if sample size is large? So if I remember the equation correctly, we have T stat equal mean minus standard deviation over, I think also standard deviation, and then n. Okay.
لا
Okay.
هذا متى بنستخدمه؟
No, I'm just proving a theory. Okay. So I'm just proving something. Okay.
So
So
figure that stat crunch, right?
yeah, I'm just proving to you what's going to happen. Okay. So what happens if we increase n? Okay, but so we need to use this so I can tell you. Okay, so it's also equal to this. Okay. So we have n in numerator. Correct?
Okay.
So if we increase n, that means t will increase. Correct?
Okay.
Okay, so imagine we have this Bell distribution. If you have t here, and then we increase the sample size, so t will increase. So if it was like t is 0.3, so it increased becomes maybe 0.5, and critical t. So critical. I'm writing with the mouse, so my writing isn't good. So critical t, let's say it's 0.4, right?
Yes.
So let's say it's here. So it goes from here to here. So what happens? So if it was here,
It will be in the right.
we fail to reject because it's not in the critical region. But then when we increase the sample size, it increased the t. T went inside the critical region, so we reject. So what happens? Yeah. So what happens when t goes to the right? P value goes down. P value is the area. Okay. P value is the area to the right. Okay, do you get it? So this, so let's say here. Yeah. So let's say for this one, P value maybe is like 0.5. Then T increased, so P value becomes smaller, 0.2 or something.
Okay.
Okay. Okay. So P value goes down. So let's look here. So is it valued that magnets might appear to be effective if sample sizes are larger? Yes, because if we increase the sample size, that means we will reject the null hypothesis. That means they are larger. So yes, because increasing that sample size will decrease the p-value. Yeah, we just proved it. Okay. So you're not really going to use any of this. Yeah, I'm just proving to you that increasing n decreases p-value.
But automatically, how do you know that it's increased?
Here it says, is it valid to argue that magnets might appear to be effective if sample size are larger?
Okay.
So if sample size is bigger, so if n is bigger.
Obviously, P will be bigger too.
No, P will go down. Because look, if you make n bigger, T will be bigger, and if T goes to the right side, P will go down because P is the area right here. So the area will become smaller. So P will go down. P value will go down. Okay, so we're done with this one.
This one doesn't depend on the question, right? It's just hypothetical.
Yeah, hypothetical. So if we increase sample size, P value will go down. So that's just the hypothetical part. Okay, sample size increases. Okay, P value goes down. Okay, so here, close pen. We don't want to use it anymore. Go here, close this one. So let's do the claim first. We have mu1, mu2, so male and female, and it says that they have the same BMI. So equal, not equal.
Okay.
Why?
Because they said the same. So H1 is not equal. So here goes stats. We have mu, so T stat, 2 samples, summary. We put mu1, so 27.6765. Standard deviation, 8.33175. 50. So mean 24.1238. And then 4.068095. 50 also. So now we put the same number. We start, put it to the 12, round up. Yeah. P value 0.007. Go. Okay, so now, so it's less than, we reject. There is sufficient. Yeah, so where is alpha? We have it here, we should 0.05. And 0.007 is less than. So reject is sufficient. Okay, now it's edit. So it's two-tailed. So 1 minus alpha.
Minus
Alpha.
what's the alpha?
0.05. So it will be
95.
0.95.
95.
95.
Yeah, so copy this one and round to what? 3 decimals. What was the one? 7.
And 7.
So we put this one 4 decimals round. So does it support? Yes,
Yes.
because there is no reason. There is no zero.
Only positive.
Only positive. Okay. Next. Okay. Okay. So let's look. Have mu1, mu2.
Okay.
Low.
So what's the claim? That low blood lead levels is higher than IQ of people. Okay. So mu1 is more.
Greater than.
Yeah, mu1 is greater than. So we have to go stat, stat, to sample, summary.
زي ما مكتوب.
Mean K sample 1
لازم تقرا. مرات يحكسوا كيان.
15.27983 and sample size is mean is 87.03749 9.33573 21. Then we'll put greater than compute stat, copy paste p value 9
0.9.
3 decimals. So it's 0.009 compared to 0.01 less than p value is less than a. Reject is sufficient. Wait, let's read it. So here we have the claim says higher than, right? Okay. And p value is less than. So we know, look, more than, less than, so we reject the null hypothesis.
I guess C. Try C.
No, wait. It says there is sufficient.
Wait,
There is no D.
D.
wait, so we
Maybe
rejected.
9 is rounded to 1, so they will become the same.
Put D. Or B.
Wait, fail to reject is not sufficient. What's sufficient?
So the claim is that IQ, low blood, so U1 is higher than U2. And p value is less than 0.01. No, it's less than. If it's less than, we reject.
Okay, reject. But I think B.
But-
I think B.
B,
Mostly reject.
Actually, let's try. Maybe it's B.
try B.
Yeah, try this.
It's D.
Yeah.
Let's
I
pick.
give it. This is difficult. I think fail to reject.
Okay.
معناها غلطة.
Maybe it should tells you why.
It's fine.
That doesn't say why it doesn't.
There is a not.
But p value is less than.
My best guess is that 9 is rounded up, maybe.
Maybe?
Yes.
Maybe because it's so close to 0.01. So they say maybe it's fail to reject. No, even if it's equal,
Okay. Why it's wrong?
لا صح والله.
it doesn't make sense for some reason.
Similar question. Okay.
Similar.
Yeah, we can do similar question.
Let's finish this one first.
Okay.
So it's one-tailed. So
One tail with a greater than less than, two tail with
Okay.
not equal to.
put this one decimal. So 13.
We wanted to lump اثنين.
عشان حطيت
one minus two
اذا wanted
one minus two
one minus تنزل اذا wanted one minus
إذا نتذكر إذا less than هو filter صح؟
سونا
With less than is reject, yes? So this one, the less than, it will be reject, there is sufficient evidence, yes?
Where? Here?
Yeah, it will just say
It's p-value is less than, we reject. So we have sufficient evidence.
greater than.
But here, look, if we fail to reject the null hypothesis, that means they're equal. But then here it says,
No, I'm not talking about the question, it's
Yeah,
just saying in general. Greater than is failed to reject always.
yeah, greater than is fail to reject. But look here. So here it says that we fail to reject null hypothesis, so we don't have sufficient evidence to support that subjects with low lead levels have higher IQ. But here we said it does have an effect.
Maybe there's something wrong in the question. But probably the question is wrong.
Now we can try again. I don't know. So here, so higher mean. Okay. Was it? Right. So we do stats, T stats,
two samples
two samples, summary.
okay
Let's put the mean 94.34131,
okay 15
15.48366,
79
and then 79.
86
86.93062,
8 point
and then 8.24014, and then 26.
greater than
Greater than. Start to decimals. Okay. So p-value.
0.001
Yes. So it's less than, so we should be able to reject, and there is sufficient evidence. Now it's correct. Maybe
I think the question was wrong. So
no,
maybe the
maybe
mistake was from the system. It happened during the assignment.
no. I think maybe when I entered the numbers, maybe I added an extra number, so p-value changed a bit.
maybe.
So maybe the actual p-value was maybe 0.011.
Okay.
So we needed to check the inputs.
I see what you mean.
So we let it. Yeah, we entered the wrong number. So here, 2, 1 decimal, 4. Lower, because there are so many decimals, you can have one wrong decimal and then everything is wrong.
yes
So does it have an effect? Yes, it does. It has only
only
total.
positive values
Yeah. You want to do it again?
no it's fine
Sorry.
Okay.
This every question for 9.2.
So sometimes, yeah, 9.2.
The ones that we need, we don't need to do every single one. Yes?
9.2 only have the
So look, sometimes you can have a different conclusion from p-value and confidence interval. So we entered maybe a wrong decimal, wrong digit. So last time it was wrong. So here we have data. Yeah.
Oh yes, this one.
Here we have data. Look.
So two sample data.
Yeah. Stat. So we have mu1, mu2. So
Two
two
samples.
stat
Data.
samples. Data.
Wait, what's the difference between T stats and T stats? How do you know?
This stat when they give you when they say the population standard deviation is equal. So here look, it says do not assume that the population standard deviation are equal.
Okay.
So if it says they are equal, that means it's Z stat. But they say it's not equal, so it's T stat. Okay, so here it says population 1, 1988. So 1988. And here, sample 1, sample 2. Here, sample 1, sample 2.
So it's
Yeah.
less than, wait.
So here less than, yeah,
Less than.
less than.
You need to read both because sometimes they can switch over.
Yeah, they can switch it, yes. So compute. We have T stat, copy paste, 2 decimals. P value, 3 decimals,
108.
8. So P is more than alpha. So we fail to reject is not sufficient. So edit coincidence interval. So it's one-tailed. We have to do 1 minus 2 alpha. So here, copy upper limit. Then we copy the lower limit. So 1 decimal. Next, we're done with this. Here we have the waiting times. We have the data. Open the stat crunch. Close this one. So population 1 is data.
Have time equal.
Single. So single waiting line. So one line. Okay, 2 line. And we have mean waiting time equal. So equal.
So not equal to.
Good. So here it's the same.
Let's say it's equal or the same, it will be not equal.
Yeah. 2 decimals. 6. Good. So p value very big.
874.
So you know it's very big. So we fail to reject. Fail to reject because it's greater is not sufficient
Evidence to warrant.
to rejection.
Or when it is rejection.
Yeah, because the original claim is equal. So we're looking for evidence to say it's not the same.
To reject the claim of the
Yeah.
accused having
What made the answer? There's not sufficient evidence. How do you what?
We fail to reject, so there is no sufficient evidence. So look, H0,
Oh yeah, the
H0, H0 means they're the same. So we fail to reject it because p-value is greater than alpha. So that means we don't have sufficient evidence to reject
what was
that
the other option of the rejection of?
support.
Okay.
Okay,
Yes.
so we'll edit. So it's
Two-tailed.
two-tailed.
1 minus
So 99. So it will
0.01.
be 99. Copy, paste. 1 decimal. This is negative. Paste and 1 decimal. Finish this one. So here.
Okay.
Another table, data, stat, t-stat, 2 sample data.
Yeah, do not assume the population.
So 1 regular Coke, 2 is Diet Coke, and greater than. Okay, regular greater
Coke, regular Coke is greater than.
So
And
you want-
sample 1 is regular Coke, so it's greater than.
than. So we put greater than, put this compute, t-stat, copy paste, and we'll get 1 0. P-value is 0.
0.
And here, because 0 is always less, so we reject. There is sufficient evidence. Then we'll edit. Confidence interval, it's two tails, so it will be 1 minus 2 alpha. Put the upper limit, 5 decimals. So 0, so 1, 2, 3, 4, 5. Keep it. Here, same thing. 5. So
I think it's C.
So we don't really have a reason.
You could say
No, because look, it can be sugar, it can be metal, it can be the size itself, but we don't really have a reason. We don't know why. It could be what? Okay, I don't know.
I think it's from the sugar.
So sugar.
Let's say
The
sugar.
sugar.
I'd say sugar is the best option. Did you mention anything about metal or half as large? They only mentioned the sugar, yes?
Yes, I think it's on the sugar.
Did they say the sugar? No.
Like, no, because the cola usually has
Wait,
10 times
so-
the sugar than Diet Coke.
Okay.
It might make an effect. Might, I'm not sure.
Okay, maybe it's the sugar. Who knows? Okay, it's the sugar.
Should we move on to 9.3 just for the time? I think we answered the
9.3. Okay.
Yeah, because we answered enough of the 9.2.
Yes.
9.4.
9.3, 9.4.
No, but should we do 5 questions of each?
Yeah, we can do 5 questions. So 1 is equal 0, and here we have to test the claim that
It's always
males
zero, right?
speak less than females.
Males?
Yes, males speak less than females, and males minus females.
So male is
Less than.
male is population 1, yes?
Yes. We go here, open StatCrunch.
We
So we
why,
have-
why less than? Because men minus.
Okay.
No.
Could be.
ممكن
So
تكون
look,
less than.
look, when you see mu d, it's paired. So t stat paired. So sample 1 male, because male minus female, and we'll put this one here.
For the
Male
first
speak
one,
fewer
it's
words.
always zero, right?
Yeah, always 0.
Always zero. But
Always equal 0.
how we know it's less than?
Look, because males
Okay.
speak less than females.
So
Yeah.
immediately less than.
No. Because also here it says males minus female. Yeah.
So we have-
So
Everything. So we confirm.
yeah, you have to
I
confirm.
think for the minus, it only tells us which one is the first sample.
It tells you which one is the first sample, which one is the second sample, and what is the MUD. So look,
Okay.
if it says males less than females, if it says female minus male, it will be greater than,
Okay.
because female is larger. So we'll always have a positive number. But here, because it's males minus female, we'll get a negative number. Less than 0. So p-value.
Okay, but
Greater.
what do we open in StatCrunch so we know that?
No, which one?
Everything from the start, from the beginning.
No, this one you have to know yourself, and
Okay.
then this one you can calculate.
So once we see UG,
Okay.
it's paired, right?
I'm asking what do we open in StatCrunch? So we get the T
Oh.
and P.
Okay, so we
T,
do look
the
when you
last
see
one?
when you see MUD, that means it's
Paired.
paired.
T sample.
Paired.
Okay.
Then you choose male,
Female.
female,
Okay.
because it's male minus female,
Okay.
and then you get it.
في واحد شيء دوره بالخط كذي هذا variance.
Confidence interval. Go here. T stat
عفوا.
paired. Male, female, less than. No, actually we don't need it because we need the interval. So
0.01.
1 tail. So it's 1 minus 2. Complete. Nearest integer, so this one becomes this. And nearest integer, this one becomes this.
Next one.
So it includes 0 that we don't reject the null hypothesis.
Better check the hypothesis.
Yeah, because they are not different. That's it.
Now 9.4.
Yes. So here, look.
0.0.
Look. So here we have September less than April.
So
So first one it's 0 or 0.
April less than September.
And April minus September.
So
So
less than. Less than.
why?
Oh,
April
great.
is the first sample, and they just said that September are less. No, it's more than.
More than.
Because
Yes.
September is U2, right?
why it's
Correct.
they
It's
switch.
September less وعكسوها.
Okay.
Paired. So we have April minus September. So more than.
والله مش مهم.
So the summons.
انا خلص وياه بنسوي براكتس فيه على راحتي.
So
بنسوي
do.
براكتس على راحتي.
Okay.
So this one, compare it with alpha. It's greater than. Fail. So
Is not. Is
it's not.
Not sufficient evidence. صح. Better reject. Okay.
So interval, edit, confidence interval. So it's one tail.
One tail.
We'll do this.
1 minus
Put number. So one decimal
0.01.
here. We put
99 right
9 8 because it's 2 1.
انا تعكست انا قلت لك اول واحد ماينس
Got this. So it includes 0. So we do not reject. So do you have evidence to suggest that people gain weight? No. No, because there is 0. That means they're the same. They don't gain weight. So it does it contain 6.8?
does not contain.
Does not contain.
It's contains 0 right
No, it does not contain in the interval.
اتذكر ماينس بلس
Okay, so let me look maybe here. Let's look at another question. Not this one. UD. Hmm.
How many questions did you do here?
I'm looking for the D bar question. It's not here. It's in the homework. Maybe it's 9.4.
9.4.
Yeah, okay, let's go 9.4. So you get this idea, okay?
Yes.
So two variances and standard deviation. No, I don't think it's here. Yeah, I don't think it's here. It's in the homework.
This was the variance.
Okay, yeah. So here, test the claim that
The D
Sham.
was in the test.
treatment, pain reduction vary more than magnets.
so more than
So sham more than magnets. And
One
the
more
first
than-
sample is going to be the higher S,
okay
bigger S. So sham is going to be
More
1,
than.
so it's more than. So we'll go here,
T-step.
close it, latest, start, variance, two sample, summary. So we'll put sham first, so 1.56, and we square it. You have to square it.
Sample 2
Yeah, you can do it.
sample 1 and
Yeah,
sample 2
yeah, you can do it on the calculator or like this.
okay
Have to square.
متى يكون سكوير يكون عندك هذه الدائرة بس من الفاريانس.
Yes, exactly.
إذا عندك كيو عادي استخدم بس.
So we'll copy p value, 3 decimals, so this will be 3.
2
No, it's 3
Supposed to be
decimals.
83.
I think 9 maybe 9
6.
okay 3
P value. Use technology to get p value.
Check the numbers.
No, it's here. Look, this was correct. Same number.
Try keeping it 0.082.
I don't know because it's the same p value.
we don't calculate
One calculator?
Yeah, I have them here. Okay, it's okay here. Let's see. Wait, wait, I know why. Let me go back. No, I know why we got it wrong.
why
But let me go back. So we did sham greater than magnets,
1.45.
right?
So that's it's greater.
So greater than, yes. So we go back. We'll close this one. Start. Variance to sample summary. So we put the first one, okay, 1.49 squared, then 20, and then 0.98 squared, and then also 20. 20. And here, greater. No, last time we didn't use the other one. So this will become
What did you use?
We didn't put the,
We forgot this one.
yeah, we forgot. So now if we do,
Zero.
yeah, we didn't put greater than. So look, wait,
3. You leave all the numbers.
oh yeah, wait, I forgot here. I have
3
three.
decimal.
It's already 3 decimals, so I
Okay.
rounded it automatically. So this one is
Greater than.
less than.
Wait. Yes, less than.
So we
It's,
reject
reject.
is sufficient. So here, sample 1, sample 2.
Okay.
So
The
sample
same.
1,
It's the same.
sample
So-
1 is the larger one. So stats, variance, 2 samples, summary.
Okay, it's saying it's the same.
So
the red
we put,
not equal.
So red greater than.
so here, the same here, it says the same.
Not
So not
equal.
the same.
Not
Yeah,
equal.
so not equal.
I don't see the 8.87.49.
So 7 squared, 34. 29.
So not the same.
So not the same. Correct. We have stat. We have 2 decimals. The p-value. 3 decimals. So it's bigger than alpha. So we failed to reject is not sufficient.
Rejected says no.
So here, sample 1, larger sample. So start, variance to sample summary.
Okay.
So the one with the larger standard deviation. So here,
21? No, it's not 21.
so this one, look.
2.30.
Yes, so put 2.3.
Greater than.
Sample
greater than.
size 21.
Okay,
0.83,
0.83 over 2.
21.
21.
So it's same.
Not
So
equal.
not equal, yes. So equal, not equal. B. Excellent. Next, we got this one.
7, it will be
2 decimal
Wait, you get the not equal to from the claim or from the numbers?
from the claim.
What is the claim?
Here,
I have
0,
this
0,
here.
right?
yes, yes.
Peak.
So because it's 0, we automatically reject. It's sufficient.
There's no point to compare.
Yeah, because it's 0. It's always less than
Let's leave
everything.
this last question and go to chapter 10.
10.
Okay.
So let's
Chapter
do this
10.
one. So variance, 2 samples, summary.
Summary. Okay.
So the bigger one, the bigger S.
5.31 over 2.
Bigger. Wait,
17.
let's do the test first.
Use
Claim that
Same as-
same.
okay,
So
not-
equal, not
not
equal.
equal.
Equal, not equal.
Okay.
So
30.
sample size 30 and 5.11.
over 2, 30.
30. Equal, not
First, we take
equal.
the greatest, greater one.
Yeah, the bigger number goes first.
9, 8. Okay.
So the p value.
87, 4. 84.
So it's bigger, so we fail
Fail
to
to
reject
reject.
is not sufficient. Okay, so we finish this one and go to 10.
9.4.
Do you want to do a break?
Fine. 10 minutes break.
Okay, I'll stop the recording for now.